The famous physicists who formed classical physics, geniuses like Galileo and Newton, managed to predict everything from the motion of an apple to the motion of planets thanks to the physical laws they proposed. For them, the universe was deterministic and calculable within the framework of physical laws. But as science advanced, would this remain the same, or was physics really calculable and deterministic? Let's hunt down the answer to this question in this video. Before starting this journey, let's learn the concepts of determinism and calculability. Scientists developed the concepts of determinism, calculability, and predictability to better understand the behavior of the universe and to classify different systems. Calculability in science means that the current state of an event or system can be solved through mathematical equations and algorithms. If a system cannot be expressed mathematically or if no suitable algorithm can be established, this system is considered non-calculable. Classical mechanics mostly consists of calculable systems. Some of these systems require extremely difficult and sensitive calculations, as in chaos theory, while others can be solved instantly. In the world of mathematics, however, non-calculability is quite common. One of the most striking examples of this is the halting problem defined by the Turing machine. No algorithm can determine in advance whether a program will run forever or stop. In this way, systems are classified as calculable and non-calculable. Determinism in science means that the current state of an event or system completely shapes its future state. If the future of a system depends on random choices, then this system is not deterministic, because the initial conditions do not determine the outcome. Even though deterministic systems may have complex calculations, they feed the scientists' fundamental motivation, the desire to know the future of everything. Classical mechanics, relativity, and electromagnetic theory are deterministic examples. However, quantum mechanics has so far been the only indeterministic theory encountered, because measurement results can only be predicted with probabilities and not with certainty. Determinism and predictability are often confused. Predictability means that the future of a deterministic system can practically be calculated using initial conditions. If a system is not predictable, there are two reasons. Either the system is so complex that the interactions cannot be calculated, producing a chaotic system, or the system is inherently indeterministic and prediction is forbidden like quantum theory. Let's look at why these interesting theories have these properties. As a start, let's begin with chaos theory. Chaos theory explains deterministic but unpredictable systems. These systems are mathematically completely deterministic and have defined rules. However, due to their extreme sensitivity to initial conditions, small measurement errors can create large differences over time. Therefore, in the long term, predicting the future is practically impossible. A common everyday example is the weather. Suppose you wanted to know the weather 1 year from now and started researching. You would see that while up to 7 days can be predicted, 1 year cannot. The reason is that weather is a system in which many parameters are interdependent, so any change in the system changes many other parameters. Even if this change is as small as a butterfly flapping its wings, this tiny stepwise change grows over time and can cause a tornado. That's why we cannot currently calculate the weather 1 year from now. Our ability to calculate depends on technological progress and the inclusion of more steps in algorithms. Another example is the Lorenz chaotic water wheel, which we have a simulation video of on our channel. As seen in the video, even though the mills start in the same position and are filled with the same water, they move differently, yet their movements are still deterministically defined. For instance, it is certain that when the mill slows down, it will change direction. However, even though this is certain, we cannot know at the beginning when this change will occur. Still, chaos theory feels like it could be predictable, at least to me. Then let's look at the unpredictability of the one true natural law that is genuinely unpredictable: quantum theory. Although we call quantum theory indeterministic, not every quantum feature is indeterministic. For this reason, quantum theory is divided into two parts: deterministic and indeterministic. The deterministic part of quantum theory is that, thanks to the Schrödinger equation, the time evolution of the wave equation can be completely predicted, and the possible states a quantum particle will move into upon measurement are defined. But absolute indeterminism comes into play at this point. When a quantum particle is measured, it collapses into a state completely at random. This event is currently seen as completely unpredictable and continues to irritate Einstein even today. Most physicists do not like to deal with this indeterministic part of the measurement problem, because practically it is much more useful to use the deterministic side to perform calculations. That's why the measurement problem is often seen as an area left to philosophers or theoreticians. As we see, quantum theory is not only a deterministic evolution explained by mathematical equations, but also has an indeterministic nature that brings randomness at the moment of measurement. This raises the question, Is the universe really completely calculable? Or is nature always hiding a surprise from us? Let's return to this question in the conclusion. In earlier times, scientists believed that everything in the universe was deterministic, and this belief greatly contributed to the development of science. However, over time, quantum mechanics revealed indeterminism by showing that some events could only be predicted probabilistically. Alongside this, the discovery of chaotic systems was also surprising. Although these systems were deterministic because they depended on sensitive initial conditions, they became practically uncalculable and unpredictable. So, being deterministic did not always guarantee being predictable. With the emergence of quantum mechanics, which became the nightmare of scientists with its uncertainty, it was as if nature was saying to us, no matter how much you develop technology and science, you can never fully predict me. In this duel, we are doing well for now. Until quantum mechanics, we managed to predict many things. The rest lies in solving the mystery of quantum mechanics. See you in future videos. Don't forget, knowledge is liberty.